Looks like it's all going. The transcription's going. Okay, great. Welcome, folks, to the Community Cabal meeting. Today is Tuesday, January 16th, 2023. We have a pretty long list of topics this week to talk about. So we're starting off with talking about Podman kube apply. I'm not sure who's running that one. Is that Matt or Dan? Do you know?
Well, I think I can lead the discussion on it. I think, is Irvishi on?
I don't see her yet, but before we hop into that, I'll just go quickly through the others. I'm going to do the Podman support for VMs. That one, Dan and Alberto are here for Cedar VM, and Tyler will be talking about Cabal and Podman. And then Matt had wanted to talk about image ID consistency with a issue that's popped up in the Podman issues that's in the agenda if you want to take a look at it. And then finally, we'll be talking a little bit about Podman v5.0 schedule updates. So given all that, I'm going to do the apply, talk to the Podman kube apply. Dan, you want to run with that?
Yeah, so I think someone has brought up the fact there's an issue on whether or not we should be doing kube apply at all. The main problem with kube apply, is it Paul Warabi? I probably mispronouncing his name, brought this up. Irvishi, you're involved in this. Basically, what we have now is Podman kube play, Podman kube generate, and we added Podman kube apply, and apply basically will take a, the locally running kube YAML and apply it to a remote or a local Kubernetes instance. And so the comment that we got was they didn't believe that we should have implemented it because we didn't implement the entire kubelet. I think the original thought, I think when Irvishi and I were building this, was that it sort of completes this, you build it locally, you test it locally, and then you push it into OpenShift. And that's why we added it, push it into Kubernetes. I think when we've talked about it in the past, we also said, well, you could also pull it back. And right now we don't really have the ability to pull it from a Kubernetes cluster. But it is a slippery slope into implementing all of kubelet. And at a certain point, we basically want people just use kubelet for it. So the question is, should we drop support for it, or should we continue on and add additional features to it? Irvishi, you have any comments on
it? Not really. I just, in terms of adding additional features, I don't think we should delve more into that space, because at that point, how are we separating, like how much of kubelet are we trying to replicate then? I think initial discussions, this came up when we were talking about kube apply. And I think we said that we just want to have that, developer to kind of cluster path, and we'll end it at this point. And after you have deployed it into your cluster, then you can use kubectl or the web console to manage your workloads on the cluster. So I don't think we should add more features. I also don't think we should remove this. It's already there. We can add documentation to clarify that this is where it ends, and we're not going to add anything more, really. But it's open for discussion, like whatever everyone else thinks.
Do you think it would make sense, though, just to add retrieve?
Yeah, we could do that to match the opposite behavior. That shouldn't be difficult to do.
Anybody else have any comments?
I think we're building a precedent that we're about what parts of Kubernetes we're implementing and not implementing, rather, here. I generally agree with what's being said. We're having some other issues where I think we're having to make similar calls. So it might make sense at some point to put out a doc somewhere saying these are the parts that we want to implement, this is what we're going to match, and this is the stuff that we don't think we can.
Yeah, I think if we just throw that in the README, in the man page, then we've handled that. Go, Vivek.
Yeah, we just need a landing spot where we can point people out if it's questioned again in the future. But I too like the addition of the retrieve command if we can, and then documenting it all.
Go, Vivek.
I just have a generic question. So the way I see, like, I was introduced to this traditional Podman mode where I just run containers and pass everything on the command line. And now this Podman cube and then associated options where you can deal with Kubernetes objects and different use cases to play locally and then apply to kube cluster. So like, it's just general question, like, is there any sense that what users find more interesting or the equally interesting, or there any sense like in terms of user adoption of Podman cube versus regular Podman?
I think the reason we pushed for kube is obviously is a Docker Compose alternative, because lots of people are looking for mechanisms for managing multiple containers, multiple pods at the same time. And so that's how we originally envisioned that, it makes more sense to work developers towards Kubernetes than it does to basically sit in an island like Compose. So that was the original idea. I don't know how many people are using Apply, although I do know that it's a fairly, we could bring in the Podman desktop team to talk more about this, but I know at least they demonstrate this quite a bit, this workflow. I don't know if they have data on how many times people actually take a Kubernetes YAML file that they're developing and push it into the, into a running instance of Kubernetes.
Mm-hmm. So, okay, so sort of follow-up question. Why I'm asking this is that some people are interested in this Podman cube, that can we extend it to VMs as well?
You're jumping ahead to the next section.
Yeah. I think. Okay. So yeah, forget about it. Thank you.
Anybody else have any comments? So I think the output would be, let's just add retrieve or pull or whatever we're going to call it, and then document in the man page that this is the end of our Podman support for playing. Basically at this point, everything else should go. You should use kubelet. If you need more features than this, then you need to go and get kubelet.
Yep. No, that sounds good.
Sounds good to me. Thanks.
Urvashi, can I task you to make sure that gets put into our backlog some more?
Yep, I'll create a card for it.
All right, thank you. All right, next up, we have crun-vm, Dan Walsh and Alberto Ferreira. And I apologize if I messed up your last name, Alberto.
Yeah, so quickly, and Alberto's going to do a demo, and then we're going to talk about this. Some of this is just, it's kind of a really cool feature, and I wanted to expose it outside of Red Hat. It isn't packaged right now for Fedora, although there's pull requests to start the packaging process thanks to Lokesh. So one of the things that when Giuseppe introduced crun, one of the interesting things is we basically added sort of a C library plugin interface. So crun would take care of processing the OCI runtime spec, and then we could add additional OCI runtimes to it. So over time, we had crun krun, which was sort of the first one, which allows you to run a container inside of a KVM separated environment. Similar to what Kata can do, but a little lighter weight and a little bit different. And then eventually that evolved into crun krun sev, which I think Tyler is going to be demonstrating, which is running using Podman to run confidential containers. Later we added crun wasm, which allows you to run wasm workloads as a container. And basically use the wasm that's from the host operating system, so you don't have to package a wasm in every single container in the universe, but we use an OCI runtime for it. Similar to that, we had discussions internally about, should we run a crun, what we originally called crun qemu. The idea was to take a container or a container that just contained a VM image, so a qcow2, or a artifact that contained a qcat2 and just run it as a VM. So the basic idea is taking VMs and running them as containers, as opposed to a container and running it as a VM. So Alberto went off and looked at this, and he's about to give a demonstration of it. Go, Alberto.
Right, thanks. So hopefully screen sharing works. Just a second. All right,
Screen looks good and the size looks good.
thanks. Okay, so I'll just get right into it. So we have a VM image here, a qcat2 file, and with the crun VM or CI runtime, we can use Podman to actually run that. So let's not waste more time. We will do Podman run, select the crun VM runtime. Let's make it interactive and some more standard options. And now Dan mentioned we can run VMs from container images that contain VM images, which is true, and I'm going to show that in a second. But we can also do away with the container image. If we have just the VM image file like I do here, we can also use the rootfs podman run flag and give it the directory where the VM is contained, the VM image is contained. And currently, so that podman run doesn't complain, we have to give it a command, but of course we don't actually use that, so I'm just passing an empty argument here. So a couple seconds later, we should get the VM. There it is. I'm just gonna let it boot. Okay. Right, there it is. Now I can't actually log in yet because this is just a base cloud Fedora image, so I don't know what the password is, but we're going to fix that in a second. Now I mentioned we can use container images, right? And that's what I'm doing here. This is the exact same command I used earlier, but now instead of rootfs, I just pass in the image. Thanks, Dan. Pass in the image that contains a VM image file inside. Yeah. So we're just using container images as a sort of packaging format for VM images. And this is the same thing. Okay. So let's try to make this command line a bit better. Right. I mentioned I couldn't log in yet because I don't know the password, but crun VM also accepts some custom options. And of course, Podman run doesn't understand this, but we can pass them as what would be arguments to the image, and crun VM will interpret those. One of those is password, and this lets me set password for the default user for the VM. Now this internally uses cloud init, so the password flag will only work if the VM supports cloud init. And there's a bunch of other flags too. Yeah, and there's a bunch of other flags as well, which I'm not going to show in the interest of time, but you can also pass in any cloud init config to the VM. You can also pass in ignition config, etc. So now I should be able to log in it, yep, with the password. Okay, there it is. Now something cool we can do is actually exec into VM. And the only quirk currently here is that as the first argument, I have to pass in the username of the user to exec as, because behind the scenes is just SSHing into VM. And there we go. That's a VM. Okay. And I probably took enough time already, so I'm just gonna show a last command, just showing a couple more things that crun VM can do. And that is, one of those is actually mounting directories and also regular files into the VM. So let's mount the current directory, which is what, the directory that has the VM image into the VM at some path that we can see it as. And also another thing we can do is pass block devices through to the VM, any block device, and we can pass through other things as well. But for now, I'm just going to show this. Right. And now we should see those here. Yep, there's the demo directory with the Fedora 39 directory, which in turn has the VM image. And we also have, well, not here, but we have the RAM0 device here. All right. Okay, so that's what I had shown now. So any questions or comments? I see there's a
question. Particular Podman version this works on, starting with?
I didn't really test that. crun-vm is just an OCI runtime, so I'd expect it to be very widely compatible with possibly or probably Podman versions that are currently in use.
Great.
Yeah, there's not really any Podman specific logic in this. And by the way, this works with rootless Podman, which is what I'm using. You can also use rootful Podman. It's also compatible with Docker and so on. Okay, so is there a mechanism to catch the startup process? Right, so some sort of snapshot mechanism for the VM. No, there's no such thing at the moment, at least. We haven't really thought about that.
It's potentially an interesting use case because obviously we have the ability to snapshot a container right now. So theoretically, it might be something we could look into. The key thing here as we do this is we don't want to make this Podman specific so that this theoretically could be used in other container engines, including Kubernetes. So theoretically, Cryo and Containerd could use it as well as Docker, and that's why he's interpreting some options. We also don't want this thing to, even if this is vastly successful, we don't want to be looking at huge amounts of options, like basically building this into a vagrant type thing. But I envision this as being a decent way to. It's somewhat similar to KubeVirt, which is causing some controversy because I think will cause some controversy because people are asking when to use KubeVirt, when do you use this tool. But I just want to see this tool, this OCI runtime develop and figure out where we want to use, how people are going to use it and how it develops. One thing that has been talked about is potentially using attributes to further enhance it. So crun already does some of this. I think labkrun does this type of functionality. So there might be, again, things that special attributes that crun-vm could take. Did I say the wrong thing again? I said attributes instead of annotations. All right. I have a brain fart on that all the time. So yeah, using annotations to customize the way the OCI runtime works, and there is some decent precedence for that. I think Alberto also has the ability it's using libvirt underneath the covers, and so you can specify, we've talked about specifying libvirt XML as a way for people who are very advanced VM users to do it. I'm going to let Tyler do a quick demo of what he's got, and then I want to bring back for a discussion on VMs in general and some thoughts that we have around Podman Machine handling some of this stuff. So,
quick question to Alberto, and you can do this while Tyler's going on. Do you have a link for any documents, pages, project, GitHub sites or anything for this?
Yes, there's a link to the GitHub, which Daniel posted. I'm just going to write that again. So that's the GitHub for the, whoops, okay, there's a typo there.
Yeah, you cut and pasted my typo.
Yes. Right, so the last one is a link to the GitHub for the project.
There's really great README there too, so it should help people really sort of understand how to use it.
Okay, thank you, Alberto. That was great. Tyler Finelli, hopefully not butchering your name as well.
Oh, you got it. No, that's right.
Woo, 2 in a row. Krun and Podman, take it away.
Sure. So I have a few slides that I'd like to give. I can go through them quickly. I'd just like to talk about what libkrun is actually trying to solve, and especially with respect to confidential computing. So I'll start this slide real quick, but I'll go through pretty quickly. Is everybody able to see that all right?
Looks good.
All right then. So I'm Tyler, and I'm talking about testable confidential workloads with Podman, krun, and sevSMP. As Dan mentioned, the krun in this instance is packaged up with crun in the crun krun runtime. So I'll just be going through what is libkrun, give an introduction on confidential computing and sevSMP, talking about attestation and showing how we kind of bring that together and giving a demo. So the first question is, what is libkrun? To try to explain this, think of a scenario that we have 3 containers running on a normal container runtime, and they're all running happily until one attempts with some malicious code to escape the container, get some privilege escalation, and get access to host OS resources. There are security measures in place, but this is still a possibility. With host OS resources, it could potentially look about in the system, tamper with data, or simply spy on other processes, other containers on a system. Imagine that scenario, not good, and we'd like to try to quarantine as much potentially malicious applications as much as possible. So if we think about libkrun's architecture, it's from the up until the container runtime, as far as anybody running containers is concerned, it's pretty much the same. We have a container context that's managed by crun, and presents itself to the container runtime as such, but inside that crun is a virtual machine. It's a lightweight KVM based virtual machine that's managed by libkrun, and the applications put inside that virtual machine. If we compare the two, it's as far as the container runtimes, and they're presented the same. It's just inside the context, there's a virtual machine running, and the application's running inside that virtual machine. And libkrun provides the context to communicate between the two, that being the crun runtime and the application in the virtual machine itself. So for our previous example, we have that application again, and it's running malicious code to escalate the privileges and break out the container, but it's still in a virtual machine. So this provides some process isolation for potentially malicious workloads. Right. So, and the question is, are we fully protected at that point? Say these 3 are now running as krun VMs, and they're protected from each other, but are they fully protected? Not really, because what about the host OS, the host hypervisor, some type of malicious acting administrator is still able to peer into the containers themselves. So there's no barrier from malicious hypervisor or an administrator from reading or tampering with the memory. With this, you can have the potential leaking of secrets, and sensitive workloads require a bit more protection. So the question is, how can we prevent everyone, even the hypervisor self, from reading the in-use data of that being the RAM of the containers? For that, we can use confidential computing. It's basically a technology that isolates sensitive data, protected in a protected CPU enclave, and only the guest owner of that virtual machine is able to read the contents of that memory. So, and it focuses on data that's basically hot memory, such as RAM and CPU, rather than data at rest, such as like files on a file system, or a database, something that's sitting on disk. And this is implemented using trusted execution environments. And the trusted execution environment that we're going to be focusing on today, there's some differences between every CPU manufacturer's trusted execution environment technology, but today we'll be focusing on AMD sevSMP. And basically it includes a platform secure processor that manages keys, so that encrypted VMs running on a system, with these keys, they're able to determine who can access which memory of a virtual machine. All the RAM of a virtual machine is thus encrypted, and it needs that key to decrypt that memory in order to read from RAM. Neither the hypervisor nor other VMs have access to this key. It's only available to the guest itself, and all that management is done by the PSP. So this is this is done on the chip rather than, and thus is even hypervisor software itself cannot access these keys. There's also some other features like data replay, memory remapping, and such. These are other attacks that can kind of compromise the system, and this is also what SevSMP looks to prevent. So if we just see how libkrun uses SevSMP, we basically measure our entire environment of the virtual machine and tell the secure processor that this is all to be encrypted. So when we're running, nobody can read any of the BIOS kernel, etc. Everything that's going to go into our virtual machine. And then we actually hide our actual application that's going to be run in that virtual machine is going to be hidden in a LUKS encrypted disk. And the one thing we'd like to prove is that our system's not actually lying to us and saying that we're encrypted, saying that we're confidential when we're actually not. So there's one thing that needs to be done is attesting that system, and basically the result of attestation of a successful attestation is that you get the LUKS passphrase to the LUKS encrypted disk. So basically, to talk about attestation. So we're told that our application is running confidentially on trusted hardware, but how can we be sure? The one thing you have to verify is that the hardware you're running on is TE hardware from a chip supplier, from that it's actually running on verified hardware, and that the software that is running on that system is what you expect it to be, as in they don't map some pages in that could leak secrets itself. Map some unencrypted memory that could be used to skirt around the confidential guarantee. So how libkrun does this? It communicates with what's known as an attestation server. We call it here the key broker server. Basically, that key that it's looking to get is the passphrase to the LUKS encrypted disk. There's a 5-step process of the communication between the libkrun client and the server itself. In this instance, libkrun is known as the key broker client. It's wanting to be attested. It's the guest that's looking to be attested, and the server has pre-registered measurements and workload information that it can use to compare from what the client's looking for. So just to recall that libkrun's code and application is hidden behind this LUKS encrypted disk, and the passphrase to unlock this disk is stored on the attestation server. So a successful attestation means that your application can run. If you don't successfully attest, your application will never run in that libkrun. It won't be able to unlock the disk that it's hiding behind. So we talk about how Podman's role in this. So Podman facilitates the bring up and gives the necessary information needed for attestation. So Builda offers a CW flag that stores container contents inside an encrypted LUKS disk. So Builda does this for us, builds that LUKS disk, and then it registers the LUKS passphrase and attestation information, anything that's needed to attest, with the attestation server. And then it creates that container image and gives the container access to the attestation server address, so it knows where to reach out to attest. So Builda is the essential registration part of when we're building our container image, and then we can encrypt the application behind the LUKS disk. So then Podman offers obviously the krun runtime, so it runs the containers with krun protection, and then krun facilitates the attestation to verify the environment and unlock the disk using the passphrase. So just a quick demonstration of Builda. Not a demonstration, but a diagram of Builda. Basically, you would use Builda's, the build command in Builda has a CW flag with some of the details that's needed to register with an attestation server. So then Builda would then create that container image with the LUKS encrypted disk, and then given the address of the attestation server, it'll register the passphrase with some the information that's needed to attest. When krun goes to attest, then it'll give its attestation evidence, and the attestation server will examine that evidence, and with the information previously registered, it'll either successfully attest and give back that passphrase so the krun virtual machine can start running, or it'll say the attestation failed and there's no LUKS passphrase. you haven't successfully attested, so you can't run your application yet. So it's just basically verifying that you're actually running confidentially. If so, then it's unlocking your disk and you're going to be able to run. So at that point, the attestation is complete. And then through the SetSMP encryption, libkrun now protects your processes from potentially malicious hypervisors, and it allows users to run their processes without worrying about potential spying or tampering. I can give a quick demo at the moment. And it went on to another, sorry, let's just share one more time. So this is a quick demo of how we're going to be using it. So on the right here, we have an attestation server running. It's known as reference KBS. I can link to that itself, but it's an attestation server running that's going to receive things from Builda and then attest it with krun. So at the moment we have this. So if you see on the top left here, basically the application that we're going to run is just a simple a web server that you're going to reach out and it'll tell you a secret. So if you see the secret right here, I originally gave this presentation for the virtualization team. So the secret is virt team. Now see that was stored in static memory. So as part of the memory of the guest, you should be able to read that from another process on the system. And we'll see what I'm talking about at the moment. So we're just starting up a regular web server. It's not confidential at this point. So there's nothing special going on here. We're just running this web server in a container. We'll run that on port 8080 and then, so we see the application started. It's just a normal container at the moment. If we go to reach out to that server, we can see that the server is able to return with the secret is virt team. There's nothing surprising there. It's able to read its memory and go back to it. Then we'll dump the contents of that process that's running that web server, and we'll try to read that secret that's stored in static memory. So we'll see the process ID, and then we'll dump the contents of the memory of that process. Then we'll search for that secret that we just read from the web server. We'll search for that secret in the process's memory, and we're able to see it. So nothing special there. It's stored in static memory, and we're able to read it. Now let's run it confidentially and see if we're still able to read that secret from another process on the same host. So if we go through, you've deleted the container. So I'm running this on OCI2CW. If you see on the top left, basically this was done before we had the Builda support. So in this example, it's using OCI2CW, but everything that I'm showing right now is actually able to be done in Builda instead. And so this is a bit outdated at the moment. So we have a configuration file. This is what's going to be given to the krun guest. So when the krun guest eventually loads, the initial code that's going to be running is going to be able to read some of this information. This is all the attestation information that it needs to reach out. So if you see the URL there, that's the URL of the attestation server running to my right, to the right side of the screen, I mean. So what we're going to do, where Builda would be doing this at this point, is we're going to build that container image confidentially and register the contents with the attestation server, which you'll see in one moment. So you see there's been a workload ID and some attestation information, such as the passphrase that's going to be used to unlock the disk and information used to attest that it's going to require. We can then run this with the krun runtime. where we'll then reach out to this attestation server again in a test. So if you see, we've mounted the Lux root file system, and if you see on the right here, there's just some information showing that we successfully attested. Attestation is a multi-step process with validating certain certificates with an attestation report, comparing launch measurements, which is the contents of your software, checking some hashes, etc. But if you see, the krun virtual machine has done all of that, and then at the bottom left here, what we'll try to do again, for the bottom left here, we're going to try to see if we're actually confidential. So what we're going to do is reach out to the server again, and we'll see that the server running in that virtual machine is able to view its memory contents. So we'll now are going to try to dump the contents of that virtual machine and read that secret again. We were able to do that with non-confidential container running. But if we try to read the memory now, and then we'll grep for that secret again from another process. And we're not able to find it. That's because that secret is now encrypted, so it's not just in plain text over the process. So that is the Podman demo. I'm sorry, I went a little faster. It was usually faster. Give me 1 second. Next steps that we're thinking for Podman in krun is ARM CCA support. It's the confidential computing architecture from ARM, and it's useful for edge scenarios that we could see. And then we're also looking at builder support for other attestation servers, such as there are some known as Keybroker, Coco KBS, more mature implementations of KBS attestation servers. So is there any questions?
I just want to point out that Podman Build has the same support that Builder has. So obviously it's sucking in Builder. So
Okay,
all that's available. Other things you should know is that unlike the previous demo where, well, I guess theoretically this would work, but we're not allowed to SSH. So Podman exec into a confidential container by default does not work. And I think that's sort of expected. The whole idea here is that we don't trust any process on the host operating system on the confidential workload. So that even the admin, someone running full root, full capabilities, is not able to see the system. The only thing he can do is denial of service, so he can kill it. But that's about it. Go Vivek.
So I have two questions. First question is, you generated this disk image. This is local, so the very fact you are protecting against hypervisor, I'm assuming you will generate the disk image on some separate build server, and host them somewhere in some sort of registry, right?
Yes.
So has it been figured out that how will you host these images in registry?
That's also what we're still looking at, because obviously, like you said, that's being generated on that same host. So it doesn't make sense at the moment. There's still ways for you to violate that integrity. But yeah, so we'll still need to be some way that Lux encryption is already done beforehand on the host, as to not leak any access of secrets. Because at the same time, Builder at that point is creating the secret, so it can just store it somewhere at that point, even if even if it goes through even if it does create it Lux encrypted, it has access to the passphrase.
Yeah. So okay, so here's my.
But the idea is that we push the encrypted image to an OCI registry, and then the tooling should be able to pull the encrypted image down. It'll pull it down, but not be decrypted. So it's not decrypted until it gets the secret. And I believe Nalin did most of the work on the Podman build. I don't even think Builder reveals to the user running Podman build what the secret is. So the secret actually is exchanged. I mean, obviously, if you strace it, you can see it, but the secret is exchanged with the attestation server directly, and it's it's not even human controlled. It's just a random secret that's generated. Alan, tell me if I'm wrong.
No, you're correct. But you can specify a passphrase, but if you don't, we just generate one and then throw it away after it's registered.
Yeah.
So here is a follow-up question after that. So with this assumption that there's a disk, encrypted disk, you'll have to host it in registry somewhere. And I think this is where it overlaps with the crun-vm stuff. That the only difference I see here is, if I understand correctly, you don't have the kernel and rest of the operating system. You have it outside somewhere, the custom one, your kernel and intermfs. All you have done is in a disk, loaded the actual workload you want to run. And then, while you were presenting, I was just comparing these two models, that in the confidential VM use case, we are, let's say, using bootc or whatever, we pack the actual kernel in intermfs, and that will allow me to do the easy upgrades later without resealing things and talking to the registration server. But let me not go there yet. So I wanted to hear your thoughts. I feel that technically at some point of time, we are not there yet. That it should be, the same thing should be doable with the crun-vm as well, and using the confidential VMs. Build those disk images, push it to some registry, pull it, attestation server unlocks it, you boot the kernel, which is contained inside the disk and not the kernel, your custom kernel. And I was just thinking that what are the advantages and disadvantages of these two approaches? The libkern-based approach, probably the one thing is obvious, is probably lightweight. You probably are going to boot faster because you have done some customization. You can take some shortcuts. Apart from that, can you think of like other advantages?
Well, fundamentally, one's running container. The Podman krun one is running containers, and Podman crun-vm is running VMs. So theoretically, we could run a VM inside of a container if so in a confidential mode. But right now, what he was demonstrating is running a container inside of a confidential environment.
From a user's perspective, but yeah, go ahead. No, you're saying something.
Yeah, it's a micro VM, but it looks like a container. The main difference is if you're booting with a kernel and an init.rd that's part of the shared library, then the disk is still encrypted and it's not visible to the host at all, because the init.rd is the bit that's contacting the server and then decrypts the disk in the VM. Whereas if you wanted to boot just the disk, you'd have to decrypt it first, which means the content of the disk would be exposed to the host.
So in case of confidential VM, like what people are doing, they're using the similar things. Like at least the proposal is the root disk is still be encrypted, and then the decryption key will be tied to the VTPM, and it's actually the VTPM secrets which you will get from the attestation server. So what I'm saying, there are many flavors to it, and even there are 3-4 flavors. So I think that this flavor can change a little bit. That's perfectly fine. But ultimately, like in my mind, it boils down to that how a certain approach is more lightweight or heavyweight. And we necessarily don't have a good answer, but I'm just sort of like brainstorming a bit. I will see that how does it evolve.
Yeah, I think there's a potential. I think there's a potential for allowing us to run a VM inside of a confidential workflow. I mean, but that's sort of leading towards a kubevert type environment where you'd basically have embedded in the container image the ability to run a VM.
I would say both. Like if kubevert is managing it, then it's a kubevert environment. But if it's a without kubevert environment and standalone as devices or anything, where people
what I'm saying is we wouldn't trust the crun qemu that's installed on the host. So the crun qemu is trusting the crun qemu. The crun VM is trusting the qemu that's installed on the host. In this case, we're trusting. In this case, we're trusting nothing. Well, we're trusting the krun command, but the krun.
I don't think you have to trust that, right? In confidential VM model, that we are not building trust into the QEMU. That's an untrusted entity, if I understand correctly.
No, it's trusted. Well, it's trusted in that the measurements have to be done. So we're measuring libkrun. So the attestation is measuring everything from boot through the running of the libkrun.
Yeah. So in confidential VM, what I'm trying to say is you don't rely on the trust on the QEMU. You rely on the from where you are loading and how many components you are measuring. We can have this debate some other
Yeah.
time. Like,
Yeah.
there are many components to it.
I think
and
we're going to
having
run out of time.
well,
So
yeah, exactly. So
Yeah.
we can
Yeah, it's
have
a
this
great
debate.
discussion. I hate to stop it, but we've got 2 more topics and just about 10 minutes left.
yeah, I just quickly. So obviously, one of the things that's happening here is we're looking at different types of things that we can do with the virtualization stack, in addition to the OCI runtimes, and that's really what this discussion about. One of the things going forward we might want to look at is, and we're out of time for this, but maybe in the next Cabal meeting we can talk about it more. Is everything we've showed right now is Linux centric, and obviously most users of Podman going forward are going to be on Macs and Windows. So one of the things that we've been talking about internally is potentially expanding the use of Podman Machine to allow us to launch VMs potentially generated via Podman or Podman containers natively for the particular host that you're on. Right now, if we generated a VM on a Mac as a raw image, how would you run it? If we generated a Hyper-V image on a Windows platform, how would you run it? And what we're looking at is can we get support for launching VMs natively on different platforms like we are with crun qemu? So those are things that we're talking about. But as we're totally run out of time for this subject, and I know we have someone else, so I'm going to give up any more
Thank you.
conversation to do.
Yeah, Tyler, if you could send me your slides at some point, and if you have any project links for GitHub or anything that you could add to the notes, that'd be great. And then, so next up, thank you. We have image ID consistency. I think, Matt, this is your topic.
I think we can actually skip this one this time. I've been looking into it while this was going on. I think it needs more investigation.
Okay, well, if anybody's interested, I'll leave it in the notes. We have some discussion going on in an issue on GitHub and Podman, so feel free to dive into that. Then we'll segue right into Podman v5.0, which I know Dan had been tickling about, and Matt, you were going to talk about, I believe.
Sure. So Podman 5. People have probably noticed that we switched the main branch of Podman over to 5.0 dev. I think it was during December, and we've been working on things since then. 5.0 is going to be a breaking change release. We have a bunch of changes scheduled for it. And just to go into some details on scheduling, we're expecting to start cutting release candidates in, call it late January, early February. It will definitely be out by the first, what do you call it, Fedora RC or Fedora beta, whatever. There's a Fedora deadline in early February that we're going to meet. And ideally, we are going to be completely done by, call it late February for Podman 5.0 final. But that is not completely certain yet. There's a lot of work going on the Podman machine side of things that we're going to wait for that to be done, even if it takes a while. So we're expecting this to be an extended release period, probably a lot of release candidates, and the Linux side of things should be fairly stable early on. We're expecting a lot of RCs on Podman machine and Podman desktop stuff, though.
Yeah, and the biggest change in Podman machine is that we'll be moving to the Apple hypervisor.
Yeah, there are a bunch of big under the hood changes to machine, but we are going to be defaulting to Apple hypervisor, completely removing support for the qemu driver on Apple, and yeah, that's basically a maintenance thing for us. Apple HV is a lot better maintained and a lot easier to work with, and it offers some other advantages like faster file sharing. Okay, any questions on that, or? Okay, I think that's all I really had in 5.0, so.
Okay, well, given that, then we are open for discussions of any sort. Does anybody have any questions or comments that they want to make? Good.
Sorry, just because I have time. So like the question I had asked initially, and I think I had jumped the gun at that point of time. Like, are there any thoughts of extending Podman Q to be able to handle VMs as well? This will be a little different from Podman machine, so that will be a separate thing. Podman machine is not going to use containers. It will not deal with the Kubernetes objects and everything. So like it will be like a separate flavor. So Podman machine, of course, will be there, and that development to be able to boot VMs. And this is something you boot the VMs in container, something like what crun-vm is doing. But what you deal with the Kubernetes objects. The way Podman Cube seems to be. I don't know much about it. Yesterday I looked at the Podman Cube man pages, so please correct me if I am completely misunderstanding things.
So Podman Kube should just use standard kube YAML but sometimes people use, I'm going to get it right this time, annotations to customize the way Kubernetes handles different workloads. Does anybody know if Kubernetes supports annotations to change the OCI runtime? Because that would be the way we would have to, because you're really asking that I want to run a container inside of a pod that actually happens to be a VM.
Yeah, something like which KubeVirt is already doing. So if I understand correctly, I define a VM.
KubeVirt's not doing that. KubeVirt is running a container that contains software to run a VM.
The answer is yes, you can change the OCI runtime for a pod. You just give it the name of the different runtime, which has to be installed on the node.
Okay. So that would be, so if we're going to support this, that's the way we would, because it's a standard Kubernetes procedure. So if we should support the ability to swap out the OCI runtime based on the Kubernetes YAML file. So that would be the way to do it. One of the cool things I think of crun-vm is that we could actually run VMs via Quadlet and have a full management of VMs as if they were the same way we're going to manage containers. But if Kubernetes YAML can do this too, that seems like a nice feature. And I have no idea if it currently works, but probably we're not that far away from. It should be fairly easy to make it work, just to swap out the runtime if kube-YAML supports it. What do you think, Urvashi? Did she disappear? She's gone.
Yeah, I think she's left.
Yeah.
Right. Any other topics or questions?
So Andrews is asking about Podman machine.
Yeah, I mean, would you leave the QEMU code for non-Macs, or would you just remove it?
So the answer to that is yes. The problem is not with QEMU. The problem we've had on a Mac is more around QEMU support for a Mac, and and secondarily has been Brew, in that people change very recently over the holiday break. QEMU released something that blew us totally out of the water, and there's no control over when these things happen, and I don't really think the upstream QEMU command team cares that much about how they work on Macs.
And neither does the Brew how they test their QEMU versions.
Right, and I think that's a problem too. And finally, everyone else that we know of that started using QEMU on a Mac has eventually switched to the Apple hypervisor. So Docker has switched, CRC or OpenShift local has switched. And with our instability on a Mac, it just seems like, okay, let's just switch. And
I think it's more of a portability, if anything, if it was to stick around, but that's not going to be the default target anyway. So.
Right.
It's like the QEMU is the new VirtualBox, the portability layer.
Right.
Right.
Any other questions?
I'll cut everybody here. I'll just put in a couple of plugs for upcoming meetings. We have our next community meeting on Tuesday, February 6th. We have a Podman at Home demonstration by John Masters scheduled, and looking for more topics for that one. And then for the Cabal meeting, that will next be happening on Tuesday, February 20th, which is 2 weeks after the community meeting. And I've put in, at the moment anyway, Podman Cube to handle VMs from Vivek. I'll have to chat here today if anybody else has any other topics they'd like to discuss on that or any other one, or in the community meeting, please let me know. And going to go to Tyler.
I just have to say, Tom, I sent you the slides, and I'm going to send some other information about krun on Slack.
Awesome, thank you.
I got to ask Tyler my number one question that he knows is coming. When can I get cheap hardware to try this stuff out? Cheap,
That's what we're looking.
Less than $1,000.
Yeah, well, that's the idea when I mentioned with ARM, as we discussed that ARM would hopefully be able to apply to bring up confidential virtual machines on cheap hardware. Right now, the example I just showed on SevSMP, and also if you take it further to Intel TDX, those are not cheap hardware. They run on big cloud machines that are expensive. So that's the main motivation for doing CCA, is that we could run on ARM hardware, which will be cheaper. When is that? I'm starting to actually ramp up working on that implementation now. So I don't have a set time frame, but I can keep up with you on that. Where we are working on it.
Great. So I just want to get up my high horse real quick and say that I believe that confidential computing is critical for edge computing. So any computer that can be touched by a human being, that is an untrusted human being, should be running in a confidential workload type environment. And in the cloud, I believe it's more of a play for the cloud vendors to make more money. So it's it's like, oh, you want to run confidential mode? Because basically what you're saying is, when you run an Amazon, Google, or Microsoft, you don't trust their admins to do the right thing. Now, there is some security stuff that Tyler talked about earlier, but again, edge deployments is where I think this thing really should take off, but that means cheap hardware.
Right. With that, unless there's any real quick questions, comments, I'm going to wrap us up for today. Thank everybody for attending, especially the folks that were presenting and talking today. Any quick last thoughts before I hang up on the recording? All right. Thanks, everybody.